morning, boys and girls, people of all ages. My name is Camille, and today, on the best show ever, Fun with Science, today we have a new show called Exploring the Atom. Now, for our first segment, Quiz Time, we would like to get a member of the audience to participate in our show. Any volunteers? Young miss in the front, come on up. So, what is your name?
My name's Emily. It's my dream to be on the show.
Wow, we're very pleased to have you here with us today. Emily, take a seat. So, for the first question, what is the nucleus made out of?
The nucleus is made out of positively charged protons and neutrally charged neutrons.
Correct! Congratulations, Emily. Nice job. Now for question number 2. What is atomic mass?
Atomic mass is the measure of one proton or one neutron. It's measured by the number of protons plus the number of neutrons.
Congratulations, that is correct. So, for the next question, what is a particle accelerator and what does it do?
Ooh, I know this one. Particle accelerators find out the parts of an atom by speeding up particles and crashing them into the atom.
Nice job, correct. These so-called atom smashers were fundamental in discovering what makes up an atom in the 20th century.
No.
Now for our final and most difficult question. What is the Big Bang Theory?
My favorite TV show!
Oh, I'm sorry, Emily. That answer is wrong. The Big Bang Theory is a model of the universe, which states that 13.75 billion years ago, the universe was in a very hot, very dense state and was rapidly expanding. The rapidly expanding state of the universe led to cooling and the slower expanding of the universe. The cooling of the universe made sure that energy was transformed into protons, electrons, and neutrons. And the universe is constantly expanding, therefore is expanding right now as we speak. Okay. Emily, thank you so much for being here. Unfortunately, because you didn't get the last question right, you did not win our all-inclusive trip to go see an actual particle accelerator. However, you do have an amazing consolation prize. Enjoy, and nice to meet you.
Now we will look into exactly what nuclear reactions are. In the most basic sense, they are simply changes in the nucleus of an atom. When an isotope is not stable, it emits a particle from an atom. This is called radioactive decay. When an alpha particle is emitted during alpha decay, 2 neutrons and 2 protons leave the nucleus, causing the atom to decrease by 4 in atomic mass and decrease by 2 in atomic number, thus making the atom negative. In beta decay, a neutron splits into an electron and a proton, and the electron is lost, causing the atomic mass to stay the same and the atomic number to increase by 1. The atom is now positive. Splitting apart a nucleus is called fission, which can occur naturally or by shooting neutrons at the nucleus. Fusion is the joining together of 2 nucleuses, which requires temperatures too hot to be supported on Earth.
On our next segment, in Exploring the Atom, we have some very special guests to interview about their amazing discoveries on the atom. First off, let us welcome Mr. John Dalton. Pleased to meet you.
It's very nice to be here in the 21st century.
So, Mr. Dalton, we were wondering if you could explain to us your atomic theory.
Certainly. I was always fascinated with the weather, which led to my research in gases. I performed many experiments to determine how the properties of individual gases affect the mixture of gases. Based on my evidence, I was able to reason that the particles of different gases are different sizes. So basically, I discovered 5 very important things, which are here on this piece of paper. All matter consists of small particles. Atoms are indestructible and unchangeable. Elements are determined by the mass of their atoms. Atoms combine in whole number ratios when elements react. And atoms can sometimes combine more than one whole number ratio when they react.
Wow, that is fascinating. It really helps shape my views on All that learning really makes me hungry. And not for some plum pudding. Please welcome our next guest, Mr. Ernest Rutherford.
Good afternoon, it's so good to be on the show.
It's great to have you. What do you have in store for us today?
I have a demonstration explaining my experiments that led to my revisions of the plum pudding model of the atom. You see, hold that for me, I shot alpha particles, like so, at tin foil. Most of them went through the foil. However, a few bounced back in different directions. This proves that the atom is mostly empty space, with a dense nucleus in the middle.
Thank you for your wonderful demonstration, Mr. Rutherford.
Not a problem.
It's great to have you on the show. Have a nice day. Okay. Welcome to the next segment of this special on atoms. Now the segment is Fun with Quarks. Let us introduce our quark specialist.
Thank you. I just love talking about quarks. Quarks are my passion. Okay. Hadrons are particles that interact strongly and are composed of quarks. Baryons are large particles composed of 3 quarks. Mesons are made up of only 2 quarks. A quark is the building block of matter and is an elementary particle. They make up protons and neutrons. Leptons are another type of matter particles. There are 6 quarks and 6 leptons. There are also antiquarks and antileptons.
Fun fact! Did you guys know that the nucleus of an atom is made up of 4 interactions, 1 gravity, 2 electromagnetic, 3 strong, and 4 weak? Thanks for joining us on Fun with Quarks. We'll be right back after the short commercial break.
Sick of not being able to describe the distribution of electrons in an atom? This can easily be solved with quantum numbers. There are 3 coordinates, n, l, and m. N describes size. L describes shape. M describes magnetic orientation. Rules. N, L, and M are integers. N cannot be 0. L can be any number between 0 and n minus 1. So if n equals 3, L can be 0, 1, or 2. M can be between negative L and positive L. If L equals 2, M is either negative 2, negative 1, 0, 1, or 2. You'll never have a problem with this again.
Back to Fun with Science, the Atom Special. On today's show, our next guest will be J.J. Thomson himself to discuss the discovery of a very important part of the atom, an electron. Welcome, Mr. Thomson.
Pleasure to be here.
100 years ago, you discovered electrons. Can you tell us a little bit about that?
Of course. I was experimenting with currents of electricity in empty glass tubes and investigating cathode rays. I made the proposal that these rays are made of streams of particles much smaller than atoms. It was a startling idea at the time, to imagine anything inside the atom, which was supposed to be the smallest kind of matter. But these things making up the rays ended up being electrons.
Wow, that's super exciting. Can you also tell us a little bit about Robert A. Millikan's experiment, which also dealt with electrons?
Yes, it was very similar to mine, except he used an oil drop when experimenting instead of water vapor. This ended up being better because the water vapor evaporated too easily. He determined the mass of an electron, which, needless to say, is very small. It is about 1,836 times smaller than the mass of a hydrogen atom.
Well, I should say that is small. Thanks for being on the show, Mr. Thomson. I'm sure you're very busy doing experiments in the afterlife. On our next segment on Fun with Science, it's called the Periodic Terms.
As you move down a group, atomic radius increases. As you move across a period, atomic radius decreases. Anions, which are negative ions, are larger than their respective atoms. Cations, which are positive ions, are smaller than their respective atoms. First ionization energy is the energy required to remove the outermost electron from a neutral atom. As you move down a group, first ionization energy decreases. As you move across a period, first ionization energy increases. Second and higher ionization energies is the energy it takes to remove the second outermost electron. It is hardest to do this with the noble gases or an atom in the noble gas state. Electron affinity is the energy given off when a neutral atom in gas phase gains an extra electron, making it negative. As you move down a group, electron affinity decreases. As you move across a period, electron affinity increases. Lattice energy is the energy given off when oppositely charged ions in the gas phase come together to form a solid. As you move down a group, lattice energy decreases. As you increase magnitude of charge, lattice energy increases.
Now, please welcome our last guest of the day, Mr. James Chadwick. Hello, Mr. Chadwick.
Hello.
What is the very important discovery that you made?
I made one of the most important scientific discoveries in history, or at least having to do with the atom, and that was the discovery of the neutron.
What was already known about the atom at the time of your discoveries?
It was accepted at the time, thanks to Rutherford, that the atom is made up of positive protons being orbited by negative electrons, making it neutral. It was also known that the atomic mass is twice the atomic number, the number of protons, and most of the mass was in the nucleus. This left the question, what was the mystery substance making up the rest of the mass? Rutherford had suggested neutrons, but didn't have proof. There was other experiments being done, such as the one by Irene and Frederick Curie. They were saying a massless particle was ejecting protons, but I did not believe it.
So what did you determine?
I discovered neutrons, and this time had proof. Neutrons are necessary because they bond with protons to form a force that holds the atomic nucleus together. This is what allows for atoms heavier than hydrogen to form, which allows for a more interesting universe.
Wow, neutrons are great! Thanks for coming on the show, Mr. Chadwick. And thanks to all of you for watching. I hope you had fun probing the depths of the atom with us, and I hope you learned a lot. Join us next time for Fun with Weather.